Remark, Miss Selma, that for this solution, okay, the diagonal matrix will be 10 and 5, not 5 and 10. Why? Because you already replaced, okay, the values of the eigenvalues. The last remark. Look to the eigenvalues Adham. They are distinct and having the same sign, which is positive sign, صح؟ مش كده؟ مش ترجمة positive 5, positive 10? So it is called a positive definite matrix. A positive definite matrix. In the coming part, we will know what's called a quadratic form. The quadratic form, or this quadratic form, will be a positive definite. Why it's positive definite? Because its eigenvalues are all positive. تمام? Okay. This system, you will have to do it all the way using your hand. So please resolve it again, okay? Because you will have a problem like this in your exams. Okay, the second problem, I've equated this slides with 3 problems. That's the second problem. The second problem is exactly the same. It's a similar matrix. I need eigenvalues, I need eigenvectors, I need the new matrix, and I need to check the diagonalization. Okay, I will start. I'm not gonna spend a long time in this matrix. I take the characteristic equation. Well, once more, if you remember, it's a minus eta I equal to 0. Expanding, that's the equation. I've tried to simplify. I ended up having eta 1 minus 6, eta 2 is plus 4. So the eigenvalues are 6 and the negative 4. The eigenvalues in here, do they share the same sign? No, they have opposite signs. So this matrix is called indefinite matrix. The first one was positive definite, but this one is indefinite. Why it is indefinite? Because the eigenvectors, the eigenvalues doesn't share the same sign. They have opposite signs. Okay, I will continue exactly in a similar manner, solving the system of equations that we already had previously. With each value of these values, look, Miss Salma, I would solve with eta is equal to 6. Making the substitution, that's the substitution, as I told you. You will have 2 identical rows, or there is a relation between them. I will simplify it. This is how to simplify it, which leads to the first component is equal to minus the second component. So u11 is equal to negative u12. Once more, u1 is 2 components. I will replace the first component with negative 1 u12. Okay, then I will take or consider a number, u12 is equal to 1. So my vector is negative 1. In a similar manner, I will do the same with eta is equal to negative over 4. Making the substitution to happen. I ended up having this system of equation. Okay? As you can see, Mr. Ahmed, there is a relation between these 2 rows. Once you add them together and you simplify your life, this is going to be the relation connecting the first and second components. Which means u12 is equal to 2u22, as you can see. I will make a substitution, then I will have u2 sub 2 is equal to 1 in this case to have integers. Now I have the 2 vectors. Stop. Once more. What's the algebraic multiplicity, Mr. Adham? The number of repetitions of the eigenvalues. Each eigenvalue here was repeated once. And what's the geometric multiplicity? The number of vectors in the eigenvectors. Here I have relative to eta equal to the first component, just only one vector. And exactly the same. So the algebraic multiplicity and the geometric multiplicity are both equal to each other, which means it is diagonizable. The second remark is 7. If these 2 vectors are orthogonal, yes. طب انت عرفت منين؟ لأن negative 1 times 1 بنيجاتيف 1. positive 1 times positive 1 positive 1. السم بتاعهم بكام؟ يبقوا they are orthogonal. بس كده u1 dot u2 is equal to 0. The dot product of these 2 vectors must equal to 0, then they are perpendicular. Which means you will have an orthogonal matrix. Am I right? Let's get the orthogonal matrix. The orthogonal matrix will be, that's the first vector, negative 1 and 1. That's the second vector, 1 and 1. I will divide the elements of the first vector on its magnitude. I will divide the elements of the second vector on its magnitude. What's the magnitude? The square root of the sum of the squares of the components. So it's going to be divided by 2. That's the matrix that we are dealing with. It's an orthogonal matrix. Miss Judy, what's the advantage of an orthogonal matrix? The transpose is the inverse. The transpose is the inverse. So these two matrices, once you replace the rows into columns, the columns into rows, they are the inverse. Do you remember, of course, how to get the inverse? Okay. If you multiply them together, you will get a unit matrix. If you take the transpose or the inverse times the given matrix times the U as it is, you will end up having a diagonal matrix where the elements of the diagonal are the eigenvalues. Okay. This matrix is called indefinite. Why it's indefinite? Because different values for eigenvalues. Okay. Yeah, Ms. Jude, another example for you. 16, 12, 12, and 9, which is also a symmetric matrix, Mr. Hussein. I will redo all steps. I will start with evaluating the value of the eigenvalues, which is really very simple. Expanding the equation and simplifying it, you will end up having two values. Please look to these two eigenvalues. You have a 0 and a 25. Once you have a 0 in your eigenvalues, this is called semi. And look to the sign of the other eigenvalue, which is positive. So this is called a semi-definite matrix. So if the eigenvalues are positive, it's called positive definite. If the eigenvalues, some of them contain 0, it's called semi-positive matrix. If the eigenvalues are negative, Miss Salma, it will be negative definite. If they are negative but contain 0, it will be called semi-negative definite. If the signs are convergent or are different, then it's called indefinite matrix. Remember this classification, you will need it down the road. So I know algebraic multiplicity, geometric multiplicity, which is a condition for diagonalization, should equal to each other. Now I've defined what's the algebraic, what's the geometric. Am I right? Okay, the second step. Now we know how to diagonalize a matrix. Okay, exactly the same. I will get the eigenvalues, vectors, relative to both of them. These are the eigenvectors. They are perpendicular or orthogonal, because simply if you multiply the elements, it's going to be negative 12. This is going to be positive 12. The sum of them is equal to 0. So they are perpendicular. I can get from them also normalized Rudel matrix, which is going to be negative 3 over 5, 4 over 5, and so on. I've got the transpose of this matrix. If you multiply them together, you will get a unit matrix. Also, if you do the triple multiplication, u minus 1 times a times u, the result will be a diagonal matrix which with the elements on the principal diagonal 0 and 25. Any questions? This is called the eigenvalues and the eigenvectors. Once more, let's back to our main slides. Those steps show you exactly and in depth how to get the eigenvalues and the eigenvectors. How it is written in your PDF. I've sent it to you, the PDFs. Okay, it's very simple. He will start, okay, I will read through these statements or these slides. He's saying in this section we consider only linear maps from n-dimensional vectors, so it's not 2 by 2, it's maybe 3 by 3, 4 by 4, or 5 by 5. We will just increase or generalize the steps. Okay, vector space E to itself. So the eigenvalues and eigenvectors are going to be considered in the mapping from vector space into itself. And note that the associated matrix represented by n matrix It's a square matrix. So now I'm searching for A times a vector equal to lambda times a vector, where lambda is the eigenvalue and u is the eigenvector. I will bring them all in one side if I want to solve this equation. Of course, u cannot equal to 0, because if it is equal to 0, you have a trivial solution. So once more, we will go through the steps, explaining all the situation, talking about the vector which is x, components and everything. Now I come to this equation, which is by moving from the right hand side to the left hand side and taking the vector as a common, you will have your system of equations. And your system of equation also indicates that the rank of this matrix is less than m. This is why we use the determinant and put it equal to 0. So the first step is to use the characteristic equation, which is a minus lambda I is equal to 0. Now I will solve for lambda to get the eigenvalues. Am I right? Okay, once more, then I will substitute in this system in order to get the eigenvectors. تمام يا شباب? Okay, which is really very good. Okay, find the eigenvalues, blah 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 blah. Okay, for this matrix, as you can see, it's a 2 by 2 matrix. It's also a symmetric matrix. Am I right? So in order to evaluate the values of eigenvalues, I will subtract lambda from the elements of the principal diagonal, as you can see. And then expanding this equation, you will have lambda plus 2. Okay, I found the values, which is 0 and negative 2. This is a semi-negative definite. ليه؟ لأن فيهم 0 والvalue الثانية بنيجاتيف 2. Continue. I will take lambda is equal to 0. I will substitute in the system. That's the system of equations. Solve it the way you like it. This is the best way to solve. You will have negative 1 and 1, 1 and negative 1, add them together, a complete line is equal to 0. That's the connection between x and y, or the components. They will be almost equal to each other. Take this relation and make the substitution exactly. You will have your eigenspace, which is 1 and 1. Am I right? Exactly in a similar manner. You can do exactly the same steps. Now I have this vector. In a similar manner, I will solve for negative 2. And now I have y is equal to negative x, so the vector will be 1 and negative 1. So the first vector is 1 and 1. The second vector is 1 and the negative 1. And if you remark, they are also orthogonal. Okay? Note that the eigenvectors are 1 and 1 and 1 and negative 1. Are two linearly independent vectors of R2. Having two vectors, just as I realized that one is not a multiple of the other, thus the matrix A22 has a linearly independent eigenvectors, which is as you saw. So now I can continue finding the B matrix, which is gonna help you, but the previous solution contains all the steps in the slides. Okay? What's gonna be while we are solving a cubic equation? Let's look to this block. Miss Julie, leave your cell phone. That's a matrix which is simple also. What's the thing with this matrix? It's a symmetric matrix, صح? So I will start for this 3 by 3. Also, same steps. I will subtract lambda or eta from the elements of the principal diagonal, and I will try to expand it. So it's gonna come up to negative lambda squared, lambda minus 6, which means I will have odd. I will have two values of lambda. One of them is equal to 0 and the second is equal to 6. Adha. This is lambda to the power of 2, am I right? And it's gonna equal to 0, which leads to lambda is equal to 0. But it is repeated how many times? Twice. This is called an algebraic multiplicity of 2. But the negative 6, which is lambda minus 6, once it's equal to 0, so lambda is equal to 6, which is repeated once. Now I have the algebraic multiplicity. Once more, it is the number of repetition of the eigenvalues. 0 is repeated, and the negative 6 is repeated once. For this matrix to be diagonizable, the geometric result should be geometric multiplicity for the first vector is 2, and the geometric multiplicity for the second should be 1. I will do in details with you the first one of them to show you how you may have two vectors in the eigenvalues. So please just for the first vector and I will continue. Okay, now I have the first vector which is the first value which is lambda equal to 0. Please do substitute in the augmented matrix directly. Adam, are you with me?
Yes.
Start substituting. 3 minus 0 is gonna be 3. Then I will have 0. Then I will have negative 3 and it's equal to 0. Do the second row, which is gonna be a 0, then 0 minus 0. Am I right?
0.
Then I will have 0. Go for the last row. It's going to be a negative over 3, a 0, then one small, 3 minus 0, and it's equal to 0. Am I right?
Yes.
So, now let's get the reduced echelon form. In order to get the reduced echelon form from this matrix, I will remark that I will have to replace the second row to be the third row. So I will replace this row. Here we go. That's the second row as the last row. Then I will remark that if I add the first row with the second row, the result also will be zeros. Am I right?
Yes.
I can divide the first row on 3, so it's going to be a 1, 0, and the negative 1 is equal to 0. Now I've simplified your life. Now you will have the following. This is, after doing these steps, you will have U1 sub 1, U1 sub 2, U1 sub 3. Try to expand, you will have the following, that U1 sub 1 is equal to U1 sub 3. Am I right? 1 times U1 1, it's going to be U1 1. Then minus U1 3, the result will equal to, so that means U1 sub 1 is equal to U1 sub 3. Okay? Now I will do the substitution. I know that the first vector contains how many components?
2.
3.
3.
U1 sub 1, U1 sub 2, U1 sub 3. Am I right? Make the substitution, please. So it's going to be U1, 3, U1, 2, U1, 3. Are we right? If you remark, this vector contains 2 different components. I can't separate them. How to separate them? This is the first vector. It's going to be U1, 3, U1, 3, and 0. Plus 0, 0, U1 sub 2. Am I right? Please look. Am I right?
Yes, sir.
Take U1 3 as a common. So it's going to be U1 3, which is going to be 1, 0, 1. Take U1 2 as a common. So you will have 0, 1, and 0. Am I right? So, I can now find the basis of the eigenspace of the first eigenvector, which means that U1, the basis of this vector space is 1, 0, 1 with the vector 0, 1, and 0. How many vectors? How many vectors?
2.
Which means the geometric multiplicity of U1 is equal to 2 vectors. Do you remember the algebraic multiplicity?
2.
So both of them having the same, okay, the same algebraic multiplicity and geometric multiplicity. In this case, this matrix can be diagonalizable. Okay? Now I have the 2 vectors representing U1 and the vector representing U3, which is going to be simple. Now, note that lambda 0 is a root, and the algebraic multiplicity is equal to Okay. Once more, if you try to evaluate, you will have two components, which x is equal to z. If you try and y doesn't equal to 0 and z is not equal to 0, you will end up having 1, 0, and 1, and 0, 1, and 0, exactly as I did. So you will have a geometric multiplicity for this guy is equal to 2. If you try to solve for 6, it's going to be direct. You will have just only one vector, which is negative 1, 0, and 1. Now I have the vectors, which is 1, 0, 1, 0, 1, 0, negative 1, 0, and 1. Now I can get the matrix. Okay, that's the first vector, that's the second vector, and that's the third vector, and I can normalize each one of them, and I can continue with the steps if I like. معايا يا شباب? Okay, any questions? Tomorrow I will continue, inshallah. If you remark for the following, for what did you have today? First of all, you will have to resolve these problems I say. It's not sufficient just to look to this solution, how it's coming together, or to watch the video. You will have to solve it using your hand, using a pen and a paper, because you will find the problems while you are solving. So it really is very important. Today we learned how to get an eigenvalues, the corresponding eigenvectors, how to get the U matrix, which is required for the diagonalization. How to get a diagonal matrix? What's the algebraic multiplicity? صح? What's the geometric multiplicity? When they equal to each other? صح؟ مش كده برضو? We talk about the classification, positive definite, positive semi-definite, negative semi-definite, and the indefinite. Okay? This is really very important. Thank you very much, and I will continue tomorrow, inshallah, solving more problems with the eigenvalue and eigenvectors. Then we will finish this chapter. It will remain once more, another chapter, inshallah. We will go through it quickly within next week. Thank you. Bye-bye.